Welcome to the Healthcare.ai weekly live broadcast with the Health Catalyst data science team, where we discuss the latest in machine learning topics with hands-on examples. Here's your host, Levi Thatcher.
Hi everybody, thanks for joining us. I'm Levi Thatcher. This is the hands-on healthcare machine learning broadcast, joined by Griffin Hoopes, Mike Massanduno. Mike, go ahead and introduce yourself. It's been a couple of weeks, and then we'll have Griffin say a few words.
Yeah, so thanks, Levi. It's great to be on the show again. My name's Mike Massanduno. I'm a member of the Health Catalyst data science team, and I guess my main job has been building Healthcare.ai and helping people use it. So it's been a lot of fun. Griffin?
Special guest star.
I'm Griffin Hoopes. I've been at Catalyst for over a year. I've worked in healthcare for over 10 years now, and that sounds really weird to
That's
me
impressive.
when I
That's
say that.
a lot longer than me.
I've been exploring machine learning for the past few years and have been really interested in it. And with Healthcare.ai, it's made it easier for me. It's exciting.
I'm glad to hear. We didn't pay him to say that. No, I didn't intend for him to say that even. So to start off, just some logistics. We're super excited to have you on, Griffin. So be sure to log into your YouTube account if you want to chat, and we encourage you to chat and implore you to chat because that's what drives the discussion. And we want to hear your problems in machine learning and healthcare. And in case you want higher resolution, you can play with the little gear there in the bottom right corner of your YouTube window and increase the resolution. Don't go too close. If you heard about these high resolution movies and whatnot, sometimes it's a little too close. So if you get too much resolution, you might want to back down, but you can toggle that up and down if you want. And then subscribe. We'd love to have you with us each week. Share, like, whatever. But we're going to start off with a mailbag today, and we got a couple of different questions coming in this week. And so this is a broad one. This is a goodie. What is the difference between machine learning and artificial intelligence, or AI? And AI has been in movies you've heard about since the 50s, but Mike, any thoughts?
Sure. Yeah. I mean, they're both kind of hand wavy terms. I think they can mean a whole bunch of different things. I think in general, kind of machine learning would capture building models that learn from data and using them to predict things. So Healthcare.ai, that's machine learning. That's what we do. And using past data to predict future length of stay, that would be an example of machine learning. Whereas artificial intelligence might be something like HAL from that one movie, or
2001.
Yeah, that's the one. Thanks, Griffin.
Exactly.
See, we knew we brought him on for a reason. and getting into things like maybe you could consider a self-driving car to be artificial intelligence because presumably it's going to get better at driving itself over time. It's going to be learning from experience, whereas standard machine learning might not do that.
Yeah, that's a great point. There was this podcast called Talking Machines, and the host, Ryan Adams, is this professor, and he put it this way. He said that whenever we look forward and anticipate technology like self-driving cars, we always call it AI, and then when we get there, we call it machine learning because basically it's just math. So it's kind of a fuzzy definition, but that's the one way to think about it.
And then you can get it even more complicated with deep learning.
Yeah, that's...
Which is kind of a hybrid of the two.
Great segue into our second question. What is the difference between regular machine learning and deep learning? Griffin, have you gotten into deep learning at all?
I haven't. It's actually pretty different than just your usual machine learning. Neural networks, they can solve a lot more complex problems than your typical machine learning. They can do image recognition, natural language processing. They even use deep learning to learn how to play video games and beat them. So it's a newer thing, and it's more complex, but it's definitely it has a lot of opportunities.
It's not quite as formulaic as like a tabular data set. Random forest is like you follow this same procedure for every model you build. But deep learning is like, well, if you're trying to translate language, the way you build that model is much different than if you were doing something like driving a car.
Right.
Yeah. And on the sexiness meter, the deeper the learning,
Yep.
the sexier the learning.
Definitely.
Is kind of how it plays in the industry these days. So let's throw deep on anything, it's marketing genius. And Mike's getting into deep learning, or neural networks is kind of the more familiar term,
Yeah, that's
or
the
formal term, I guess you could say.
that's the going on at Healthcare.ai right now, is trying to get neural networks to work on our tabular data. Just hoping that as these data sets get really, really big, maybe we'll be able to get a little more information out of them using a neural network.
Yeah, something that I've thought about with a neural network in healthcare is I had an eye test done last month, and they look at an image of your retina and they can tell if there's bleeding or any kind of problems in that. And I thought, well, that would be cool if you could take a bunch of retinal scans, and you could teach a machine to show, hey, there's a problem here in your eyeball, and
That's an amazing use case.
yeah, there's a bunch of things like that where it's eventually I think it will probably get to the point where computers are looking at those images and saying, you need to follow up with your doctor, or oh, he's okay.
Yeah. That's an awesome use case. So there's something called diabetic retinopathy, I believe, and Google DeepMind has actually been looking into that. Apparently, diabetics have certain calcifications or issues with their eyes, and this model was able to detect a lot sooner than perhaps a clinician would. But obviously, it makes it a lot easier on the clinician to have this alerting system set up. Thanks for the help with that. That was awesome. And yeah, that's a good amount of questions. Keep them coming in the chat window so we can respond, in real time as the broadcast goes on. And should we dive into today's topic?
Yeah, that sounds great. So today's topic, we've advertised that we're going to do more of an in-depth case study of how someone has used Healthcare AI, and so we're going to do just that to talk about a model that Griffin built. Griffin is we envy him a little bit because he actually gets to play with the client's data, and we don't. We're kind of one level removed, so we have to work through Griffin using Healthcare AI. We develop the tools, and then we help him use the tools to actually impact patient care. Mm-hmm. So, Griffin, I think we could start with just what's the model that you built?
So to give a little bit of background on the model that I built, I'm working on an application that we have here at Catalyst called Patient Flow Explorer, and what it does is it analyzes a patient's journey through the hospital, and something that is tied very closely to that is their length of stay. It's a big issue at hospitals, patients taking up bed space, and you have to get people out as you're getting people in. So it's a big concern for hospitals, and so what I ended up building was a classifier that could predict if a patient was going to spend more than 5 days in a hospital. And you can pick and choose and change that number how you want, but how I came to that 5 days number is that I looked at our client's data and I saw that the average length of stay was around 5 days. And I thought, okay, well, anything over that I want to flag and alert the client. So
that's fantastic. So number one business problem, right? Would you say?
Yeah.
What do you need to solve?
So what you need to solve this problem, if you think about it, you might not know a whole lot about the patient when they come into the hospital. You know how they arrived. You know their age. You know their gender. You might know a little bit about their history. You might have an admitting diagnosis if a doctor makes the decision to admit them as you've got chest pains. We're going to diagnose you with heart failure and admit you into the hospital. So you only know a certain amount of things about the patient before you know really how long they're going to stay in the hospital. So
okay.
It's very basic information, but on our clients' data we have years and years of hospital visits. We can learn. We can point the computer at it, and we can say, "Hey, go and learn these patterns." Mm-hmm. Are older patients, do they end up staying there longer? Do females versus males, do they stay there longer? Does one type of diagnosis versus another stay there longer? If my patient arrives in the hospital in a helicopter versus
That might
taxi?
affect the
That's
outcome.
Yeah, it's like you absolutely.
Has to
It's
do
like,
with the
yeah.
scenario.
Social determinants of health, billionaires,
Well-
hospital stays.
Well, yes, there's that, but yeah, thinking more about life flights. If you're coming in with a gunshot wound or something.
That's a.
But yeah, I mean, you could
serious
be a
concern.
billionaire who shows up in your helicopter and just wants to stay a week in a hospital and
Yeah, I didn't think about how
eat the cafeteria
sort of
food.
medevac entrances. I didn't know they were that common. That's a really interesting data point. So basically, you're gathering and seeing what features could help predict something.
Mm-hmm.
So just before we dive too far into the model, I just want to make sure that we're framing our conversation around the standard machine learning, pipeline we've been talking about on the show. And so that pipeline is something like identify a business question. You've done that. You want to measure length of stay to help your client be able to forecast who's going to need a bed for longer than the average. And then you're going to have to get a data set. You're going to build a model. You're going to do some feature engineering and then evaluate that model. And finally, you're going to move it into production where it's making predictions every day. So we'll revisit that timeline just for our own grounding. But before we get into the data you chose, you used Healthcare.ai to build this model, right?
Yeah.
That's great. What was the installation process like?
Well, before I talk about the Healthcare.ai installation process, I actually used my own model to. I didn't use Healthcare.ai. I got data out of the database. I put it in a CSV. I transformed the CSV. I started experimenting with the different classifiers and just seeing what would work. And I was thinking,
You used Python, right?
yeah,
Okay.
I use Python for it, and Healthcare.ai has a Python package. So I was thinking, wow, I've put in a lot of work on this, and this isn't going to be very scalable. It's like how would I go through this whole process and repeat this at every client that I go to? This isn't going to work. And so I was seeing the messaging from our data science team and saw that Healthcare.ai.
We send out a lot of spam.
There is. It comes through in your email, and I say, hey, this looks great. They've got a Python package here. They also have an R package. I have a background in Python development, and so I downloaded the Python package. We actually have really great documentation for Healthcare.ai. I walked through it on my own, and yeah, it's a credit to you guys. If the documentation isn't good, you're just gonna be stuck there scratching your head and figuring it out. So it really walks you through how to connect to a database, and it makes it a lot easier. So I didn't have to take the data and put it in a CSV and then transform that. It says you can just query a database on your own, and so yeah, actually working with the Healthcare.ai model, it simplifies it. It allows a user to. I mean, right now we can pick between, do you want to do a regressive model, which an example of regression would be, and this to me would be the holy grail, to say, when Levi checks into a hospital, I would love to be able to produce a number that says he's going to be here for 40 hours. And I would love to actually put a real number on each patient that comes in.
Definitely
And I
something to
think
work towards.
yeah, I think that we can
That'd
get
be
there.
amazing. Depressing to me, but helpful to the clinician.
Hopefully you won't have to spend 40 hours in a hospital. But so I had to choose between a regression model and a classification model. And so the classification model was a little more simple for me, where I could say, is Levi going to stay in the hospital for more than 5 days? Yes or no? So to me, that helped kind of simplify the problem so that I could approach it.
Yeah.
I wasn't going for the Levi staying for 40 hours because that's starting at the hardest point.
Yeah, and that's a great point. Like a lot of
trying to
times
back.
it's about framing your question in a way that's easy to answer or easier to answer so that you can work towards a more difficult solution.
And knowing that I had that data available, I said, I think I have the data where I can classify Levi into a bucket, yes or no.
Usually we use Joe around here. But
Joe.
I mean,
Yeah,
Joe,
well, I
Levi
can-
works too, I guess.
Whatever works. So, did that come across from like a clinician's perspective? I wonder if 5 days is like a critical point, or like maybe we need to flesh out from their side.
Well, so as I said earlier, the 5 days number came from just doing a quick analysis on the client's data to say the average length of stay per patient was at 5 days, and so I figured anything over that is abnormal, and we'd want to flag that.
Yeah.
But
It's a
yeah,
great start.
it's a totally configurable number. If when you work with your hospitals, they might say, no, we want to know after 24 hours who's staying
Yeah,
longer.
exactly. Just the business case kind of
Mm-hmm.
dictates. We did have a question coming through here. So somebody asked about, did you see any correlation with discharge disposition? Do you know that field in the EMR, discharge disposition?
Oh, okay, so discharge disposition, we don't know what the discharge disposition is going to be when somebody checks into a hospital.
That's hard.
Yes, so
Well,
I mean,
so-
we'd have to predict the future for that. I mean,
So-
we can look at the past.
Wait, that's what we do, though. We predict the future.
So how did you say after 24 hours, that's when we're going to make the prediction, and whatever variables are available then we'll use, or how do you make that decision?
So based on how our data comes in, there's a 24-hour refresh, and so most of the time you're going to get a window of the patient will have already been admitted for 12 to 24 hours before I'm actually getting the data in. Eventually, it would be really cool to do it, in real time or very close to real time, where I say right when you check in, we can make a prediction about how long you're going to stay here. But just the nature of
Yeah,
the data that I was working with, I am
That's a hard
working
technical
in
problem.
a development environment on our client site, so there's a bit of a lag. So
We barely got off paper, so going to real-time data logging that's
Yeah,
quite a
yeah.
jump. So maybe you could talk a little bit about the data set that you had. You grab data from the electronic health record system and about the patient demographics, the social info,
Yeah.
how much of it, what kind of sources did you pull from?
Yeah, so I have years of data. I didn't want to go back too far. I wanted the data to feel more recent because the client that I'm working with actually has a newer facility that they've opened, and
okay.
so I wanted to, I guess, skew the data more heavily towards how that campus is performing. So I ended up having about around 50,000 encounters that I analyzed, to determine the patient's length of stay. And, like I said, I looked at things like the acuity level of the patient, meaning how many resources are assigned to them when they come to
Okay.
the hospital. If you have a higher acuity, you've got, potentially 5 nurses working on a gunshot wound versus, maybe an acuity level of 1 where maybe you've broken your wrist or something. And so,
Yeah.
so I looked at acuity. I've looked at the admission source, like where
Like
where you're coming
helicopter
from.
versus
Sorry, how often is helicopter? Is it percentage of all?
It
Probably
doesn't
pretty rare.
it doesn't show up a lot, but
Okay.
it's enough in there that it makes a difference.
Must be a good
Interesting. That's
indicator.
fascinating.
Yeah, it's important for a feature. Of course, I looked at patients' age, their gender, their admit diagnosis.
Oh,
So
yeah.
a lot of it's like when you're admitted. Yeah, that can help.
So
That
I-
can definitely help.
Yeah, so kind of after you've framed your business question and gone kind of looking for the data, someone in your position is really in a great spot to build the right data set because you have so much familiarity with the data, and that's that's the real creative part of machine learning. And the algorithms are available to anybody, but to build a really good model, you need good data. So
And you need, for me, it's also a great opportunity to collaborate with people. I collaborated with really smart people here at Catalyst, and I said, you have experience in healthcare. What would you use to determine how long a patient would stay? And that's where I got some of those ideas. I had my own ideas. Like maybe I can check, how their blood pressure measured when they came in. What was their weight? What was, what's their employment status? Maybe if they're insured versus not insured, do they stay longer? So I had a lot of guesses myself, and I tested all of those theories, and measured the importance of those features. And and I also had to weigh that against, our expert advice. And, I read a couple papers based on other people's studies and government studies about the contributing factors to length of stay. It's kind of important to also note that it might not necessarily translate to every client or hospital that you have. One factor that might be really important at one client might be meaningless at another. So
that's kind of the beauty of Healthcare.ai, though. It's like you can customize it to the specific department, to specific hospital, geographic region, whatever you want.
Yeah, that's beautiful. And then the person most familiar with the data is actually the one creating these features and doing the modeling, the machine learning. We did have another question come in. So somebody asked about using this for more kind of a top-level view. So you kind of mentioned in the sense of, okay, maybe clinicians would want to know who's going to stay the longest in my department, but maybe the hospital itself, in terms of a census count, how many people are going to be discharged over the next 24 hours? Or, next 3 days? I guess you can kind of like summarize it to have a whole different perspective.
Yeah, you could. I think maybe a more interesting question to ask around census would be actually predicting the census count every night.
There you go.
And
kind of more forecasting, maybe.
Yeah, I think that's a different problem to solve. But I mean, you could take the answers from this length of stay and kind of have that top-down look to say, okay, I'm expecting this percentage of patients to be discharged. I'm expecting this percent to be taking up bed space. But yeah, when it comes to census, I would think more about actually predicting the census.
Just the count of people in each department over a certain number of time or months.
It's a big issue at hospitals.
Because they're full up, like people don't want to stay there for very long. It's helpful to get them out quickly. Interesting. So we're kind of running out of time here. Any final, I guess wrap-up points? Maybe.
Well, let's see. Can we give like a real quick, what was the model you ended up using?
So I ended up choosing a linear model. I had to choose between that and a random forest, and the linear model was performing at a higher AUC score. So that's the one I've gone with. I'm testing it in the wild now, and the client's production environment is very similar to their development environment. So I'm expecting good results when we deploy it to production.
Cool. And so where's the model now? It's in the wild testing, right?
It's in the wild testing. It's been out there for a few weeks, and it's producing a pretty solid score above 0.8 AUC right now.
AUC. Okay, that's awesome. So I guess, after it comes back, we're going to hopefully see that high performance continue. And then, how's that information going to end up getting served up to the clinicians who might use it?
That's a good question, because we want to visualize that data when we're done with it. So, as I started out saying, I was working on an application called Patient Flow Explorer. I think that I can end up putting a visualization in that application to say, here's a look at a list of patients and their probability that they're going to be in the hospital for more than 5 days. Possibly have visualizations of what the most important features are to make those predictions. I think that there's opportunities to retrofit and embed the machine learning classifications into our applications.
Well, that's great. That's so exciting that you were able to do that work and kind of get it into production. I just have two more questions for you.
All right.
And these are the big money questions. So would you do it all again? Would you build another model?
Oh yeah, absolutely.
Awesome. That's so great to hear.
I'm
I
actually
swear we didn't pay him.
I'm actually working on a couple more that I'm testing.
That's great to hear. And how did you find the Healthcare.ai experience? From your position to deploying the models.
It simplifies it. It makes machine learning portable and scalable. I think it's really easy. It's kind of, you just plug it in and you connect your data to it, and it kind of does all the work for you. It was a lot easier than doing it by myself, like how I started.
I couldn't have gotten a better response if I'd asked him.
No, he came to us, so we didn't pay him to be on here. Awesome work, Griffin. That's really cool
Thanks.
work. We're excited to see where we go from here. Maybe we'll have a follow-up in a few weeks to see what's happened since.
Yeah,
Oh,
that'd be
great.
cool.
Yeah.
So I guess we're out of time for today, but next week we're going to be, Levi's out, so I'll be running the show, and we'll be talking about tips and tricks for high-performance models in the wild,
Oh,
which
sorry, I
is
missed that one.
definitely a sticky topic, you know.
That's right.
I feel like I
Sounds
got
like a
stuck
good
with that
one.
one a bit. But please, again, subscribe to our channel, join the community of Healthcare.ai users. We'd love to have you come back, give us more questions. The questions have been really great this week, and we hope to address them again at the beginning of the show. So do you guys have anything else
No,
to add?
thanks, guys.
Thanks, everyone.
Thanks so much, everybody.
See you next time.
And thanks, Griffin.
Yep.